Good morning. So, my presentation is from paper machine environment, and actually something came to my mind yesterday from yesterday's presentation, and first idea was that how far away we are from forest, because the title is Forest&Photonics. But after I heard presentations yesterday, I understood that we are somewhere there between forest inventory and customer package or magazine or newspaper. Second thing came to my mind that okay, there is available lot interesting technologies like imaging spectrometers and other very expensive technologies, but typically our measurement application market price is less than technology price if you think about very complicated or nice spectroscopic methods, for example. Then third one is data and money. Okay, I agree that data means money, but when my background is from measurements and measurement development, and how reliable data is, that's the main question. So if the data is not reliable enough, it's meaningless. And okay, our data is typically connected to closed loop control, so measurements are used to control paper, for example, to the specified quality. And rest of the data is typically, for example, roll average or things like that, going to quality management system of our customers, and that is the data can be available for final customers. But okay, my presentation contains only a few slides about Valmet. Almost everybody knows what is Valmet and where it is. Then optical measurement technologies, some environmental issues and design principles, and then application examples. Valmet is quite well-known company in Finland. We are a strong global technology company with 4 business units and about 12,000 employees. And business units are services, automation, pulp and energy, and paper. And I am from automation business unit, business line. Okay, in automation business line we have 3 product groups: distributed control systems and quality management systems. And those 2 product lines are located in Tampere, and also R&D is located in Tampere. And analyzers and measurements are located in Kajaani. And what is a laser red one? My personal area is there, and specialty is quality measurement. Okay, we have measurement systems, actuators and profilers and controls, and some machine vision applications. Then something about optical measurement technologies. So what means scanning measurement? Scanning measurement means that the scanner is traversing over seed. And here is the list if I stop it. So measurements we have already basis weight, few different technologies to measure basis weight, and basis weight means that how many grams per square meter your paper or board is. Moisture is the second important issue, and for moisture we have microwave or IR spectroscopic technologies. Then thickness, we call it as caliper. Then fiber orientation, color, ash content, paper formation, surface gloss, coat weight, temperature, paper porosity, amount of silicon for release paper applications, surface topography, and even softness of tissue paper. And if you put those measurements to electromagnetic spectrum, it's easy to understand that there is a lot optical measurements if we think that optics is from UV to far infrared. Okay, basis weight and ash content is measured using radioactive radiation. But from UV we start measuring color, and visible range we use for formation, gloss, smoothness, roughness, optical caliper, surface topography, fiber orientation, and softness measurement. The second important area is near-infrared spectroscopy, where we have, of course, moisture measurement applications. Amount of cellulose is important to calculate basis weight, and clay content to measure coating thickness, different kind of plastics, different kind of adhesives, and special coatings. Middle infrared spectroscopy is used for calcium carbonate measurement and silicon measurement. And temperature is, of course, well known. And when transmission of paper is not enough, we have to use microwave for moisture measurement. Okay, then some environmental issues. And as Jyrki Huttunen said, and we think about paper machine environment, dust and dirt is always there. Temperature is typically quite high, moisture content is quite high, and when we have scanning system, we must have very precise alignment if we have transmission measurement applications. Reliability is, of course, must, because mainly all of those measurements are connected to closed loop control. Paper machine width can be up to 12 meters, and machine speed can be the same as our highway summer speed limit, 2000 meters per minute. And scanning speed can be up to 1 meter per second. And if you think about cross-directional resolution of this measurement, typical requirement nowadays is from 5 millimeter to 10 millimeters. And sample rate, typical sample rate is 1 kilohertz or higher. Then how to make this optical design, and what are the main rules? So first is that we have to have idea what to measure, and this is an example of moisture content measurement using IR spectroscopic application, and we know that water absorption band is there, 1.9 micrometers, and we know response from dry paper to wet paper. Okay, we have need, we have idea, we know response, so we know that the measurement principle is optical, it can be transmission or reflection. Then we have to know that what is the needed signal-noise ratio. And it's very important because we have to calculate power budget from illumination through illumination optics and understand measurement target, detection, optics, and detector to calculate power budget. Then, when power budget is ready, we must know optical resolution, physical size, and also price of those components. And second step is start to develop optics. From idea or specification to optics design software to create 3D surfaces and optical surfaces, because space is also always so limited that we cannot use conventional glass optics. So optics design, 3D model to mechanics design software to create body for those optical components. Then return back to optics simulator to double check that all optical parts are right. And when this part is ready, 3D file to CNC machine to produce this kind of mirrors, polish those optical surfaces, and finally cleaning and coating. And finally, there is optical construction so that we have accurate enough housing for those optical components. We can install those optical components to this whole housing without any adjustments. So nowadays, this optomechanical development and production is so precise enough. Okay, then some application examples. First one is machine vision application, and it's more or less the same kind of application as we saw from Raute. So there is web runnability cameras installed to critical points of paper machine. For example, this water edge cutting. Information is collected to system to synchronize it to faults. Environment is always a bit difficult, so there must be automatic cleaning system, and that's a web inspection system to find out defects from paper. Defects can be holes or whatever. And different kind of illumination geometries. There can be transmission. High angle or low angle. Okay, then next example is very small scale topography measurement application. So typically paper makers can measure basis weight, thickness, gloss content, and even roughness. And the standard value of roughness is ppс. It's specified, and it's a typical quality value, but sorry. But printability of this paper is not known. And printability means that, okay, it's a printing method dependent, but it takes typically 3-4 months from production to printing. And after printing, somebody can check that what is the printing results and there is missing dots and quality is not good enough, so printability failed. Okay, the measurement principle is photometric stereo, well-known principle. Whole idea is integrated to scanning measurement sensor head, including 3-color illumination with different angles and camera. So we have, okay, the image quality is not too high, but we have 3 different gradients from surface simultaneously, and because the spatial resolution of this application is 10 micrometers, so the illumination time is about 300 nanoseconds to stop web. So it's really fast LED-based illumination. And from those gradient images, we can calculate inside the sensor head 3-dimensional surface. Okay, we get those surfaces, for example, 50 images per second. Nobody wants to know that what is the real surface topography. Okay, they want to check it, but they want to see all of those, because we cannot average those surfaces. So we have to calculate from those topography images useful parameters for printability. Last one is just a question for you. So we have this scanning application using for edge detection and different kind of scanning modes to try to separate machine directional and cross directional effects. But if you think about time from edge to edge, it can be easily 30 seconds. How much paper you run? Okay, it's one kilometer. So the coverage of this measurement is it enough or not? I think that if we compare this measurement technology to car driving, using our summer speed limit from Tampere to Helsinki highway, and if our information is like that, that's the way to control paper machine. We can see some defects, some lines, but still he is driving his car. Okay, any questions? No.
Thank you. That was a clear example of tunnel vision, I guess. And it's not a good thing, whether you are driving a car or operating a paper machine. Okay, questions from the audience.
Yes, Markku, you said that is it enough? That was a question. So do you have the answer? What are you looking for?
Well, the question was that is it really enough to have this scanning system? That's enough as long as anything else is not available. So it's a really problem to separate machine directional and cross directional effects from paper, because your scanning time is for example this 30 seconds, and there happens a lot during that in machine directional. For example, if you think about basis weight, of course, it's difficult to say that you can do all of those measurements from whole web. But if there is an idea to measure basis weight and moisture content, that might be enough.
So what are you going to do to improve the situation?
Well, we have tested and we have done applications using spectral cameras and so on. But as I said, the technology, this spectral camera technology using fibers and so on, is even the technology itself for us is more expensive than our sales price of the whole scanning systems.